So this one is June 2017, Unit 5. We'll discuss the MCQs. Which of these element is a transition metal? So scandium and zinc are not classified as a transition element because they are not following the trend. So the only option we are left with, one is titanium is there, another one is so the correct answer here is refers to B. You mentioned B. No, the correct answer here is C. Because tin is there in group 4. When we check the uh, position of the tin is group 4 element. Here is a periodic table. C10. It is in group 4 because to be a transition element, it should be in this region, like either D block element or F block element. So this region, elements within this region are the transition. Even lanthanide and actinide series are also called transition. They are called outer transition element. But tin, why tin, B is not the right one. Tin is not a transition because it belongs to group 4. It's not a D block element. It is a S block element. So the correct answer is titanium. Next question 2. Helium-2 ion oxidized iodide ion into iodine molecule. 0.0012 moles of thallium ion oxidized 0.002 moles of iodide. What is the oxidation number? So we have to check the ratio in which they react. So 1:2 is the ratio. As you can see, 0.0012 and 0.0024. So 1:2. So it means when TL 1 mole is there, it is reacting with 2 moles of iodide ion. And one iodide ion is losing 1 electron. So 2 iodide ions will lose 2 electrons. So if they lose 2 electrons, because iodide ion loses electron, convert into iodine molecule. So if they lose 2 electrons, one iodide ion is losing 1 electron, so 2 iodide will lose 2 electrons. So this TL thallium will gain 2 electrons. So it was +3, then it will become +1. So this will be +1 and we will have iodine molecule. This will be the equation. So what is the question is, what is the oxidation number of thallium ion produced in this reaction? So A will be the right answer. So a complex of a copper is given CuH2O bracket 6, ion is blue. The water ligand split the 3D orbital and a 3D electron is promoted to higher energy level. So it appeared to be blue. So when it appeared to be blue, what happened? It is basically absorbing all the light and only blue is able to pass through. And how we identify, because as I mentioned, the electron is promoted to a higher energy. So like electron, because d orbital is dxy, dyz, dzx, dx square minus y square and dz square. Like d orbital is classified into d subshell is actually divided into 5 orbitals. But due to the presence of the ligand, what happened? These orbital splitting will occur. The energy distribute between the orbital. Overall energy remains same. So when the electron jump from one orbital to another, the same 3D, but another part of this orbital, 3D orbital. So because as they mention in the question, the 3D electron is promoted to higher energy. So if it is promoted to higher energy, because as even in physics we have learned that in line spectrum, absorption spectrum, what happened, electron absorb a photon and jump. So whenever it has to move to higher level, it should absorb energy. But with energy it absorbing, it appeared to be, and they mention it appeared to be blue in color. So why it appeared to be blue in color? Like there are all radiations which are coming towards this electron. It absorb all of them, and only blue it is not absorbed. Because if blue is not absorbed, that blue will pass through, and that's why this substance will appear to be blue in color. So you're absorbing all but blue light. So C will be the right answer. Ammonium vanadate 5 dissolve in aqueous sodium hydroxide and releasing a colorless gas. The gas given off a pale blue precipitate with aqueous copper sulfate. What is a colorless gas? So basically, as it is giving a blue PPT, so what could be a colorless gas? You have to identify, because to be a ligand, it should have a lone pair. So when we check which of these having a lone pairs, so oxygen is having a lone pair, O2. Nitrogen is having a lone pair in, because to be a ligand, there should be a lone pair. NH3 ammonia is also having a lone pair. Hydrogen does not have, so it cannot be hydrogen. So we are left with 3. But then, as we have already discussed, nitrogen is inert in nature. Nitrogen does not react. Oxygen is an active component. It is an oxidant. Like if there was a color change, then it should react with. If there is basically a change in oxidation number, then oxygen should be involved. So there's no change in oxidation number. That's why oxygen is not involved. But so we are left with ammonia, because aqueous ammonia or ammonia solution, they cause the ligand to exchange. As a result, it will give us either like first acid based reaction and then the precipitate. So the aqueous copper sulfate ion, basically what happened, aqueous copper sulfate ion is there, which is containing a copper ion, but copper ion does not exist as a Cu+2, it is existing as a complex. But when it dissolves, this is giving ammonia gas. So ammonia is a neutral ligand that will displace. First is an acid-base reaction, because ammonia is a proton acceptor. When ammonia accept proton, what will happen? It will form like two of the water molecule loses a proton, so CuOH bracket 2 and H2O6 will be there. This will be the precipitate, and it will result in a formation of 2 ammonium ions. So this will be the blue PPT. That is, it gives a blue precipitate with aqueous copper 2 sulfate solution, because ammonia is a base. Bases have the tendency to accept proton and or deprotonate the complex. As a result, it will become a hydroxide, and copper hydroxide is a blue precipitate. (25 cm cube of 0.01 mole per dm cube of vanadium ions are titrated with acidified solution of 0.02 mole per dm cube of manganate 7 ion. What volume in cm cube of this solution? So first, what we have to do, we will find the moles We have the volume and we have the concentration. We'll get the moles of vanadium 2. From moles of vanadium 2, we'll get the moles of MnO4. And after getting the moles and we have the concentration, so we'll get the volume. But that volume is in dm cube. We'll convert into centimeter cube. So this is just a calculation straight. Calculations are there. Concentration into volume, we'll get the moles and then use a mole ratio. 3:5 is the mole ratio. What answer you will get here? This will be X cross multiply. You'll get the moles of MnO4 and multiply by concentration. You will get the or the formula concentration is moles divided by volume. So volume is moles divided by concentration. You'll get the volume in dm cube, but the final answer should be in cm cube. So divide by multiply by 1000. When manganese 7 ion react with ethane diuate ion C2O4 in acidic solution, what is the chain in oxidation number for each carbon atom in this? So we want to work out how each carbon atom changes its oxidation number. Look, C2O4 and the net charge is 2 minus or minus 2. Each oxygen is minus 2, so 4 oxygen will be minus 8. So for each oxygen here, because overall compound is minus 2, so this should be plus 6, because plus 6 minus 8 will be minus 2. So for each carbon, it is plus 3. That's the beginning. And when we write for a carbon dioxide, in carbon dioxide is a neutral compound. So each oxygen is minus 2, 2 oxygen will be minus 4. So carbon should be plus 4. So plus 4. So what is the change? Plus 3 become plus 4. So that is why A is the right answer. That standard electrode potential of a silver ion and silver atom is measured, which is the only suitable chemical for a solution as a salt bridge. So whenever we use a salt bridge, should be a nitrate. So because all nitrates are soluble, so we need a soluble salt. That's why we prefer to use potassium nitrate. So always remember that the salt bridge should be a nitrate salt because all nitrates are soluble. Then the cell was set up copper as a negative electrode. So if copper as a negative electrode means copper is more reactive or copper is loose. So copper is more reactive. Copper is a negative electrode means the transfer of or the direction of electron transfer is from copper to the platinum. So here we have copper atom and copper ions, and what is basically happening? Copper atom turned into copper ion, loses electron, which transfer, and here we are bubbling the oxygen gas. So the solution on the right hand beaker, as they mentioned here, the solution on the right hand side beaker contain a suitable electrolyte and a phenolphthalein. Phenolphthalein basically is an indicator used to identify the nature. Colorless in acidic and alkaline, it is pink. So which ionic half equation shows a reaction at oxygen electrode that cause the phenolphthalein to turn into pink? So in acidic it is colorless, but in alkaline it is pink. So means there should be a hydroxide OA, like the solution should be a hydroxide or alkaline solution should be there. So only option which it matches with, that is C. So that's why for question 8, C is the Right answer. Use these electrode potential to answer the following question. Which of these species are the strongest reducing agent? Strongest reducing agent itself, it is oxidized, and oxidation is a loss of electron. Because strongest will help in reduction by themselves, it is oxidized, and oxidation is a loss of electron. So which of them can lose electron easily? Positive electrode potential means they have a tendency, like they have a tendency to gain electron. The like iodine molecule has a greater tendency to gain electron. So options which are given here, we have chromium plus 3 is there. So if chromium plus 3 take electron, turn into chromium, so that is negative. If this is negative, means it does not have a tendency, like negative means it opposite tendency is more feasible. So means tendency for chromium to gain chromium 3 to gain electron turn into chromium plus 2, that is less possible as compared to chromium ion loses electron and turn into chromium plus 2 loses electron and turn into chromium 3. So this is the most likely it can happen. And rest all are positive. It means they all have a tendency to gain electron. So this equation has a tendency to gain electron, gain, and gain. And negative means like forward is negative, so backward will be positive. It means reverse or the tendency to lose electron is more. If we have a negative electrode potential, it means the product is having a greater tendency to lose electron. So that's why A is the right answer. In part B, which halogen would oxidize chromium 2 to chromium 3 but not chromium 4 under standard conditions? So we have to check the electrode potentials here. Basically, if we get, when we check for chromium, because they are saying which will oxidize chromium 2 to chromium 3, which will convert chromium 3 to 2 to 3, but not to 4, like 3 will not convert into 4. So which equation? Chromium 3 and 2 are involved. This is the equation, and this is the equation in which chromium, this is Cr, that is sorry, this is 6. So in which 3 does not change to 6. So this one is 6. First we'll check with chromium 3. Directly we can check with chromium 6. So this is the one which is chromium 6 plus 1.33 is there. And if we check with iodine, so what happened? The one which is a higher electrode potential reduction happened. So for this one reduction happened. So this one oxidation happened. Oxidation means uh, because the one which is a higher electrode potential always tend to reduce or gain electron. So here chromium 4 will turn into chromium 3. Sorry, chromium 6 will turn into chromium 3. And when we check here, opposite, like reduction minus oxidation, the formula is reduction minus oxidation. So the reduction part, these are the reactant. So these will be the reactant, and minus oxidation. So this will be the reactant, like because when oxidation happen, the reactant is the product, that part. So basically the reaction will be there for Cr2O7 to iodide ion, and it will form Cr plus 3 plus iodine molecule. And this electrode potential, as you can see, one, because electrode potential will be 1.33 minus 0.54. So 1.33 minus 0.54 will get a positive electrode potential. It means this reaction is feasible or reverse is not feasible. So iodine molecule, as you can see here, iodine molecule cannot convert this chromium plus 3 because when we work out the reaction, the forward reaction, we are getting the electrode potential of a cell positive. So it means forward is feasible, but backward is not feasible. And what is the backward? That chromium 3 and iodine. As you can see, chromium 3 cannot react with iodine to form iodide and chromium 6. And that was the question only, that which halogen would oxidize chromium 2 to 3, but not chromium 6. Like it will not convert chromium, it can convert chromium 2 to 3, but cannot convert chromium 3 to 6. So you can see iodine cannot convert chromium 3 to 6. When we check for bromine, as you can see for bromine here, this equation remains the same. This is for bromine. So now even bromine is having a lower oxidation number, electrode potential. So reduction happened for this and oxidation. So if reduction happened for this Cr2O7 will be the reactant, and oxidation happens. So it means the product of the oxidation is always a reactant. So that is Br will be the reactant. So means the reaction will be there between dichromatine and bromidine. There will be no reaction between the chromium 3 and the bromine, because the electrode potential for this one is coming out positive, so reverse one will be negative. Is it clear? Information about benzene not providing X-ray, not provided by X-ray diffraction is that, so in X-ray diffraction, when we pass these X-rays due to the same wavelength as the X-ray wavelengths equal to the gap, so it diffract. That's called X-ray diffraction. So what information it does not provide? Yeah, that's true. It does not provide that all the carbon-carbon energies are the same. Because X-ray diffraction can show the bond angle, can show the bond length, can identify whether it's planar, but does not show anything about the energy of the bonds. Then formula for organic product of a reaction between benzene and fuming sulfuric acid. Fuming sulfuric acid, basically what fuming sulfuric acid refers to, H2SO4 is there. So and what happened with the fuming sulfuric acid, this HSO3 that attack on the benzene ring. Basically, it is H2SO4, but directly, like this is how nitration or producing the idea is that because benzene ring is having a rich in electron density, like so many electrons are there in the region. So the idea is that we should produce an electrophile. An electrophile means positive. So what electrophile is produced here? Like we have H2SO4. So when H and one of the O is removed from this, as a result, it produces SO3 or HSO3. And this HSO3, which is produced, that will attack on the benzene ring, which result in a formation of electrophilic substitution reaction. Benzene undergo electrophilic substitution reaction under these conditions. So always remember, with a fuming sulfuric acid, it will be benzene sulfate, sulfonate, you can also say. So this is not, sulfur dioxide is not there, sulfur trioxide is not there. So we have two options, because H2SO4 is there, and in this H2SO4, OH, when OH is removed, OH is the negative part from this, but when it is removed, so we are left with HSO3, which is a positive, and then this attack on the benzene ring and undergo electrophilic substitution reaction. Benzene is nitrated using a mixture of concentrated acid, concentrated nitric acid and sulfuric acid. In this reaction, concentrated sulfuric acid. Basically, before and after the reaction, the amount of the sulfuric acid does not change. Like first it produces an electrophile, so that like HNO3 is there and we have H2SO4. Acids are proton donors, so this will donate proton. So what it provided, it will provide H2NO3 and it will become HSO4 negative. And this is actually providing an attacking electrophile to a benzene ring. But when hydrogen is removed, that hydrogen will recombine with HSO4, so it will become H2SO4. So substance which is chemically unchanged, we call catalyst. And because concentrated sulfuric acid, initially the beginning it is losing proton, so definition of acid, that acids are proton donors, that's why A is the right answer. How many chiral carbon atoms are there in the following structures? How to identify the chiral carbon? The term chiral carbon refers to, like, carbon should be bonded with different groups, like 4 different groups. So here we don't have a chiral carbon in a benzene ring, like this part. When we check this carbon, yeah, it will be chiral because OH is there, CH is there, this is CH, but this is C, but other group is there and H is there. So this is chiral carbon. So when we check, if we start with this one, this will have 2 hydrogen, so this cannot be chiral carbon. When we check this one, so 1 hydrogen is there, so this will be chiral carbon, because even though, look, next to that this is CH2, next to that this is also CH2, but the idea is that this CH2 and then OH is there, and this CH2 then C is there. So even we have to not only check the neighbor, we have to check around, like the whole chain is different. So this is the chiral carbon 1, chiral carbon 2, and this will be the, sorry, not this one. So this one will be a chiral carbon as well, because H, and this is also a chiral carbon. So how many chiral carbon did we see? 3 chiral carbon. So B will be the right answer. So 4 different chains are basically attached to them. Then a sample of a phenylamine is prepared from 2.46 gram of nitrobenzene. The yield is 70%. What is the mass of phenylamine? So look, practically, first, this is a ratio of the mass. So if we have a sample of phenylamine was prepared from 2.46 nitrobenzene. So 123 is giving 93. So 2.46 will give us X. This will give us what? This will give us the theoretical value, because according to theory, this is what we should get. So 123 or 93 times 2.46 divided by 123. So we should get 1.86. That's the theoretical value of the product. The percentage yield is 70%. So this is 70, and practical value we don't know, multiplied by 100. So practical value is equals to 1.86 times 100 divided by 70. So 1.86 times 100 divided by 70. Actually, percentage yield is a practical value is up. Numerator is a practical value divided by theoretical value. So practical value is up, theoretical value is 1.86. So 1.86 is divided, other side it will be multiplied with 70 and then divided by 100 to 1.302. So B will be the right answer. So this is practical value. Theoretically, we work out that is 1.86. Practically 70% yield, so it is 70%. It will be 1.302 of the reactant will be there. Yeah, moles question, we always use the ratio. Which reagent can be used to distinguish between two of these compounds? So we have to identify the functional groups here, what groups are different. Bromine water, if I carry out a bromine water test, it cannot be bromine water test, because then copper 2 sulfate solution, this both will give a precipitate. Iodine and alkaline, because here carbonyl group, methyl group next to carbonyl, so this will give a positive result, this will give a negative result. So we can use the iodine in alkali, triiodomethane will be formed. And toluene reagent, again, that toluene reagent, because one is a ketone and this one is also a secondary alcohol, so it will oxidize into ketone, so the both will give not give a positive result. Which compound would give infrared spectrum as shown? So you have to use a data booklet here to identify the peaks. But remember, like this is the OH peak. This is for C double bonded with O, and OH and C double bonded with O, which compound contain this? When you use a data booklet, you will find out that is carboxylic acid. So D will be the right answer. Which isomers react with propane diol dichloride to form this? Basically, look, a polymer is not ending at the carbon chain, like it's not all the carbon chain, so it means it is a condensation polymer. So condensation polymers can be formed between amine and carboxylic acids, or it can be react with amine and ethonyl chloride, like acyl chloride you can also say. So basically we have to work out this part. So whenever as I mentioned in the last time, that when we have a condensation polymer, one side it will have H, another side it will have OH, or one side H, other side Cl. So H and OH will be there, or chloride is there, so one side H will be there, one side Cl. So we have to work out the structure of this compound. So one, two, like which position? So this will be amine, diamine will be there. So which one it matches with, like one, two, one, two. So like all are equally positioned. So you can see here this one, one, two, one, two. So it matches with option B. Then benzaldehyde react with aqueous solution of potassium hydroxide. During this reaction, benzaldehyde is both oxidized and reduced. The organic product. So if a substance oxidize and reduce, what could be the product? So if it is oxidized, it will convert, because it's an aldehyde. Aldehyde will be oxidized to carboxylic acid. So it will become C6H5COOH. And in the presence of potassium hydroxide, so when it will form C6H5COH, it will react with potassium hydroxide. As a result, it will produce C6H5COO. K will be there and H2O. So this is one product. And it will be reduced because it's a primary aldehyde reduced to alcohol. So it will produce C6H5COH, CH2OH, because reduction means addition of hydrogen. So it will produce alcohol. One will be alcohol and one will be the salt. It will produce acid when it is oxidized, but because its acid react with an alkali, so it becomes a salt. That's why it matches with option C. Next, question 90. Fibrion is one of the protein in silk. The part of the structure of fibrion is shown. How many different amino acids combine to form this? So we have to identify the numbers of the amino acids. So amino acids are basically what they contain. One side they contain amine group, and the other side they contain acid, C double bonded with ONOH. So we have to find, like this is one type, because how I identify it end here, because this is NH group and then C double bonded with O and OH will be there, but that OH is actually removed. That's why we don't see this. Then where the second amino acid, so this started with NH and it stopped here, C double, this part, because the chain link is here. That is a side chain, but this is the main chain. Then we have this, but this looks similar to the first one. And then we have this NH. So this looks a new, different one. And then we have NH and CO. And then this NH, this matches with. So how many different types of amino acid structure you see? So actually it is 1, 2, and 3. So B should be the right answer.